Hello everyone, good morning and good afternoon, dear authors and invited guests. This is the technical session 4B, and myself Recha from India. This session will be moderated by me on the behalf of the Global Knowledge Research Foundation, and it's my great pleasure to welcome you to the 6th World Conference on Smart Trends in System Security and Sustainability through Zoom. I hope you will enjoy the knowledgeful and interactive session through the day. In this session, we have six presentations. Each presentation will be allocate 15 minutes for presentation, which means 12 minutes for presentation and 3 minutes for question answer. Question answer will be asking by our session chair. And in this session, there's one more kindly request to everyone. Please stay connected with the end of the presentation, because at the end we have to take one snapshot to click one virtual snapshot for making this conference more memorable. And if you have any query and any update, kindly write it to me in chat box. Just before we get started, I would like to introduce our chair of this session, Dr. Varsha Damodar Jadhav. Dr. Varsha Damodar Jadhav is an assistant professor at Vishwakarma Institute of Information Technology, India. She has a professional experience as 18 years old. Her area of interest is machine learning, artificial intelligence, data science, data structure, design, and analysis of algorithms. Her research interest is data structure. Welcome to you, ma'am. And in this session, we have one more session chair, Dr. Latika Desai. She is a HOD in Dr. D.Y. Patil College of Engineering and Innovation, India. She is working as a faculty since 2021, and she has total 24 years of teaching experience. She has published 29 papers in various journals, Web of Science, Springer, International National Journals, and the conferences. Her area of interest is digital electronics, data security, and embedded system. Welcome to you, ma'am. Now we can start with our papers. Now I would just like to call our first presenter to present his paper on parallel clustering method based on density perks. Libero Negro. Actually, sir, you are muted. Kindly please unmute yourself.
Sorry, my voice is okay now?
Yes, it's audible.
Yeah, okay. Now I try to share my video. Okay, now voice and slide are okay. Okay, I talk about our current research work, which is the development of a parallel clustering method, which is based on density peaks. Now, just to be brief, the concept of density peaks clustering as a reference work in the paper of Rodriguez and Layo of 2014, which appeared on the Science Journal, okay? Since then, DP has continued stimulating interest in the domain because density peaks, it seems more able for clustering data set with arbitrary shape, arbitrary point distribution, not necessarily spherical, as assumed, for example, by k-means. Now, we have designed and implemented a new clustering tool, which we refer as the PDP, parallel density peak clustering. And what is the original is the use of Java streams and parallelism. Systematically, we use parallelism in the sense that every operation in which we can exploit operation, we do it. And also, we exploit parallelism when we compute quality indexes, which are necessary to evaluate the quality, the accuracy of a clustering solution. And then we try to demonstrate the tool by applying it on some challenging benchmark dataset. Okay, Now, I would only briefly remind that DP is based on two assumptions: centroids, which are the center of the clusters, are high density points and are surrounded by neighbors with lower density. In addition, centroids must be far away each other. This is a fundamental property. Now, DP tries first to estimate the centroid. In general, we know the number K of centroid, and then non-centroid points are then clustered by propagating recursively the level of the nearest point with higher density. The disadvantage of DP is the need to computing in many cases the all-point pairwise distances, and this costs us n squared, which is a cost which is very important when we approach large data set, okay? Now, these are some important definitions, but I refrain to go into much detail, technical detail. But what is important is DP is based on a cutoff distance, which is the radius of an hyperbole in R raised D space. We compute the density of each point, the rho quantity. Then we compute the delta quantity, and delta is the distance of the given point to the nearest point with higher density. In the literature, this point, nearest point with higher density, is referred as the big brother of Xi. Then we compute also gamma as the product of rho per delta, and the candidate centroid have a high value of gamma. And for the estimation of the density, we use a Gaussian kernel here recalled, okay? Now, an important step in our tool is the so-called prediction strategy, because the cutoff distance, DC, you remember the radius of the hyperbole, must be in some way predicted, okay? And there are several strategies. One strategy which we have followed in this paper is to ensure that we choose a density, a cutoff distance in such a way that we establish that the cardinality of the surrounding of the neighborhood of a point is at least of a given threshold. For example, 1% of n. But today, in this moment, we are implementing a kappa K nearest neighbor, which is a better prediction strategy in the sense that it uses an approach KNN, which in the literature has already offered interesting results. To smooth out the cost of n squared, parallelism is a key. Now, just to give you a flash of the code, we implemented the code in Java in a straightforward way, and all the basic parameters are computed by basic method. Clustering conclude the propagation of a label to all the points. For example, this shows you a way in which we exploit the string parallelism. We achieve, for example, in this case, to compute the raw density of each point, we achieve a stream of the data set, and we achieve a parallel version if required. And then you see here, you can intuitively see that we process each point in parallel. And we are exploiting the fork and join mechanism, which splits the data set into multiple segments, spawn multi-threads on this segment, and then combine the result, okay? What is important is to avoid shared data among the threads, among the lambda expression. And in this case, you can see that each point only changes itself. So there are no race conditions to consider. Then we finish the presentation by showing you some result on some benchmark dataset. Such dataset are often used in the literature to check a new clustering tool. And the first two, BIRC1, BIRC2, are interesting because are not small dataset, and they are provided of the so-called ground truth centroids, which are centroid that the designer of the dataset used when they invented the dataset. This dataset are benchmark dataset, and the other skewed, asymmetric, etc. You can see in this case, you see that they are not spherical dataset, not spherical cluster, and so solving the clustering of this dataset is difficult. But we applied our tool upon this six data sets, and you see here some costs, some indexes. We first computed the so-called normalized mean squared error, which is a sort of variance. And then we computed also the cluster index. Cluster index was proposed by Pasifranti in last years, and it is a very, very important index because it puts in relationship the achieved centroid as the solution with the ground truth centroid, which this benchmark data set often have. Okay, and so a value 0 of this cluster index is a precondition for correctness of the clustering. Okay, when we don't have the ground truth solution, we apply the first parallel random swap as a sophisticated clustering method to achieve a golden solution. Golden solution is then a way to achieve some centroid which can be used for checking our tools as a ground truth centroid. Now, also from the time efficiency point of view, in a case we used the BIRC2 data set, which has 100,000 points, and we measured a speed up from the execution performance point of view of 8.41. Please consider that the experiment were carried out on a machine with 8 physical plus 8 virtual hyperthreading cores and with Java 17. Now we are completing our work by finishing the implementation of PDP with the new prediction strategy based on KNN, and then we can compare also the efficiency and the accuracy of our tool with other similar tools existing in the literature. Okay, that's all. Thank you for your attention. Any question? Please let me have.
Yes, Libero sir, it was very nice presentation. And the contents you have shared was really very interesting.
Please, I not understood.
Yes, your presentation was very nice.
Okay. Thank you.
And whatever you have presented, the contents of your research paper, they are very well presented.
Thank you.
Yes. So I have a question for you, that you are having the centroids there. So how do you actually find the centroid?
Centroid as the center of clusters by definition, okay? Now, we don't use the k-means algorithm of taking the mean of a given neighborhood of a given cluster. No, in this case, the algorithm proceeds by the beginning, by finding the parameter of which I talked about, the raw density, then the delta. Each delta value measures the distance, minimal distance between a point and the nearest point with higher density. So we can check the distance between a centroid and another centroid. In no case, a centroid must be close to one another, because this would be a disaster from the point of view of clustering. So centroids are calculated by the algorithm, density peaks algorithm, without resorting to k-means.
Okay, you have shown the accuracy there, but I would like to hear what are the future plans, that how you are going to enhance your work in future.
I have indicated a few points in this case. The first one is that of improving the prediction strategy of the radius of the hyperbole in the d-dimensional space, because this is very critical. In the work original of Rodriguez and Laio, it was assumed a tombriole, in the sense that we choose the cutoff distance in such a way to ensure we have a density which is beyond the given threshold, okay? But this is, from the practical point of view, not always simple to apply. And then what we are doing is to use a different prediction strategy, in the sense that we compute, fixing first a parameter k, the first k distances to nearest point, then we choose the average distance among the kappa nearest points and use this as local value of the cutoff distance. We combine the various local values, for example, through the medium value. Choosing the medium is strategic because it smooths out the effect of outliers. As you know, outliers can have a deep effect, a very wrong effect on the clustering. And so by choosing the medium value, we have already experimented, we achieve a nice prediction of the DC, which is capable of ensuring more careful result. So we are completing this implementation, and we are open to apply the new tool to other challenging data set. Okay?
Yes, thank you, sir. Thank you very much. It was really very nice.
Oh, you're welcome. Okay.
That's all from my side, sir.
Okay.
Libero, your presentation was very appreciable, as well as question answering are too. Thank you. Thank you.
Thank you.
Over to Richa.
Now I would like to call our next presenter to present his paper on ethical aspects of work disability risk prediction using machine learning. Kadza Sarela.
Hello, can you hear me?
Yeah, hi.
So, yeah, and sorry for the noise. I'm giving my presentation from the plane, but I hope that you can still hear me. I try to share my screen too. So can you see it? Okay. And can you hear me? Okay. So I will talk about the ethical aspects of work disability prediction using machine learning. So this is a cooperation with Billy Kuppertoiv with Jukka Nurminen, and I come from University of Helsinki, Finland. So I have a short introduction first. So we are talking about sustainability. So it consists of three parts: environmental, social, and economic sustainability. And in my study, we concentrate on social and economic aspects because we are talking about work disability. So for the society's point of view, it's disastrous if people can't work anymore and for this disability. And also for economic reasons, it's not good at all. So we try to find those methods to keep people working as long as possible. And if you think about the situation in Finland, nowadays the biggest reason for work disability is mental health problems, and it's even bigger than half of the reason for the work disability. And also one bad thing in Finland is that the disabilities between young people, they are increasing. So you can see the figure that they are increasing all the time, and we don't even know the corona effect yet. So in our research problem was that there is an occupational healthcare company, and they need more tools for identification of work disability. And our approach was identification of patients in disability risk. We used patient techniques for that. And we made a solution, a initial model which was capable of Finnish NLP. So the data we had was from Finnish occupational healthcare company. It was 70,000 texts, and we had 9,000 examples which were labeled by professionals in the company, and we divided them into 3 classes. There was first class, which was no disability risk, the second was moderate disability risk, and third was high disability risk. And you can see the text length in the figure. It wasn't easy to divide those classes of 2 and 3, so we also tried to combine them, and then we had only those classes that we had risk and no risk. So in that kind of case, you can use a different machine learning algorithm. You could use naive Bayes, direct input classifier, support vector machine decision trees, or artificial neural networks. In our method, we use deep learning, so the last choice here. You can also use different kind of data for this kind of case. In this picture, you can see this arrow, and it describes the person's life, kind of. In the left-hand side, is still working in the company, and we have this data in HR database, and also, for example, working time databases. We also have data in the healthcare company's database, and in this case, we use medical records database. But if this person can't get well enough and applies for disability pension, then also pension fund for the data of this person. And on the second method, Jarno Varis used pension register data for this kind of prediction. And in our previous paper, we compared these 2 methods, method health and method pension. And in this particular paper, I went through 5 different points of views. You can notice that there are kind of 5 stakeholders of the case. First of all, there is the employee who tries to get as healthy as possible to work as long as possible. And then there's the employer of the employee. We also have this occupational healthcare company who's providing those services for both employee and employers. And then we have the pension fund who is providing pension if it's needed. And then there's the society's point of view. And if you think about the society, we need to keep everybody in the work life to get the sufficient economic level, and also social aspects are very important. So I have that kind of figure that describes that all these parties are kind of the same boat. They all wish that the person will be healthy and wise, to work as long as possible, picking some kind of phrases and things like that, and we try to motivate them to work as long as possible. That was the first part of my article, and on the second part, I will go through the 5 principles of AI ethics when you are thinking about the development side. So I use talking 5 principles. So first of all, we can ask, should we use AI for good and not for causing harm? And of course, in our case, this is AI for good, definitely. And we want to find those people who need help and provide this help as early as possible. And of course, we aim for non-malafidence. And then we can also ask, who should be blamed when AI causes harm? So we need to think about the accountability and responsibility issues. And the third part is the question is that should we understand what and why AI does whatever it does? So we ask for transparency and explainability of our machine learning methods. We can also ask, should AI be fair or non-discriminative? We want that our AI is justice and fairness. And we also need to respect for various human rights, especially privacy and security. We can also ask, should AI even respect and promote human rights? Would our method be so good that we could help people and give people possibilities to work even longer because of getting help in early phase? So to conclude, so I can say that to improve society's social and economic sustainability, it's important to find methods for work disability prediction to screen efficiently potential risk indicators to provide preventive help and thus avoid disability pensions. We have found 2 possible methods. This method health and method savings. Of course, there could be some more, and we try to find them also and compare them with our method. We have these 5 key stakeholders here. We have the employee, the employer, the occupational healthcare, the pension fund, and of course the society where we are living. In my article, I also went through the 5 important aspects in the algorithm design phase. And then you just we concentrate more on the ethical aspects. We will discuss autonomy and responsibility related issues. And we also will, through Escola method, which is Ville Vakkuri's work, and we will try it in our case when we are predicting the disability rate. So that was my talk. Thank you. I will stop the sharing and then you have a time for your questions.
Yes, it was. Yes, ma'am, please proceed.
Madam, please continue.
Yes, ma'am, please proceed, ma'am.
Thank you, Katja, for the nice presentation, which is the useful area. I like to know related, can you elaborate algorithm design phases? Have you faced any problem?
Yes. Actually, we did this first algorithm in 2 years ago, and we did it, and we got the results. And after that, we would like to develop it more, but we can't because we don't have access to data anymore. But in our early phase, we did some wrong decisions. Our data was a little bit not so good. but we can't fix it anymore. We might try to find a new data. But the idea was to try to deep learning algorithms, and I would like to also try other algorithms for the same case. It would be nice to compare them.
Okay, thank you.
Thank you.
Varsha.
Yes, Kadja, it was really very nice and appreciating presentation. The work you have done is very, very nicely presented. Thank you.
Thank you.
Yes, Richa, ma'am, over to you.
Thank you, ma'am. Now I would like to call our next presenter to present his paper on new hybrid monitoring approach for distributed installation in rural areas. Paper presenter is Bala Musa.
Yes, good morning. Please give me just 4 minutes for partageing my ecran. It is good?
Yes, it's visible.
Okay. My name is Bala Musa Piai. I presented works in new hybrid monitoring approach for distributing installation in rural area. This is the content for my work. 1, context and problematic. 2, literature reviews. 3, objective. 4, methodology. 5, application. 6, implementation, and conclusion and perspective. This work is made in kind of information project ITHE in Laboratory Engineering of Innovation, IAZ of Senegal. The problematic is work is for the development of rural area. Many equipment has installed among other health installation, solar installation, drill installation, etc., etc. However, once this installation, once this infrastructure and equipment are installed, unfortunately, they do not benefit from efficacious monitoring, despite the high budgets invested for their implementation. In this, many work have been proposed in the literature for remote monitoring. Previous work we are citing BINL works in the installation measurement acquisition system. We cited Fatis was another Wang and Al was using the K algorithm for measurement if similarly. But this work has many limits. The limit on this work is the remote monitoring. Voilà. Donc, the limit of this work is does not generally require a human presence. In our work, we use a hybrid method in order to efficaciously monitoring this equipment. The objective is the work is we use automatical monitoring by the remote monitoring, and we use another manual monitoring, which is used through a human observer. We use database for storage data, and data storage are treatment. Analysis tool to locate installation and equipment or are presented failure. In response to this, we proposed algorithm of the equipment monitoring processes in the figure 1. in this algorithm, we presented the architecture of the work. We are list of equipments to monitoring, and the equipments are we are installed the acquisition measurement of each equipment, and we required measurement delivered, and measurement are saved in database collected. We use an observation of failure by the human presence, and all data collected are treated. Data treated. If we detected failure, we as resembled another failure are same another equipment are same failure. This principle is based of the symmetric quantitative similarity index. The index do the range between the number of descriptive having the same state for the two equipments and the total number of descriptive. In the figure, we have presented the simplified example of the quantitative similarity. The average similarity in the figure is given by the following formula. In this figure, we are using the rapport of all equipment are similarly failing, and divided by the total equipments are presented. The similarity on this slide, we presented the similarity calculation algorithm. And after presented the similarity calculated algorithm, we are presented in the Japan, we are presented the few results by, we are presented zoom on average similarity result. For each type of equipment, the failure obtained by automatical acquisition are compared with those obtained by visual acquisition. We use the objective of this was is to verify by the similarity failure between acquisition, between automatical acquisition and visual acquisition. And we presented in this result a very similarity. The result in this slide we use data are georeferenced and organized in the thematic lighted, but the objective on the referenced data is to make a map for local. Each installation is each installation presented failure. In this Japo, we presented the couplet of database and JIS database. The objective is to make map who are presented all installation who failure are detected. And the conclusion and perspective, in this conclusion, we have proposed efficacious monitoring of installation using an hybrid monitoring solution. The application of the hybrid facility monitoring solution is a real benefit because not all faults can be detected by monitoring system. Another are detected by human presence person. This interested work has its limit. However, failure can be similarly and do not have the same causing. The limit to this work open up many research perspectives, namely to determine the cause of equipment failure. In addition, the complexity of the choice of the freehold values for the calculation of the similarity, which question is. And is the end of my presentation. Thank you for attention.
Thank you, Bala Musa, for informative presentation. We observed your presentation. You are mentioned the previous work with black color, limitations with red, and proposed work with green one. It is too good. And your conclusion slide is also with limitations too. Can you give a little bit explanation related with the algorithms which you are used for the equipment monitoring?
Hello, please.
Algorithm which you are used for the equipment monitoring?
Hello.
Yes.
Hello. Hello. Hello.
Yes, you can continue.
I am sure problem for understand. Hello.
Yes, hello. Bala Musa, can you
Yes.
hear me?
Yes.
Yes, ma'am is asking, can you describe the algorithm for equipment monitoring? Algorithm, similarity algorithm for equipment monitoring. Explain.
This algorithm is presented all installation because when you are many installation, there are another installation who are presented failure. This is a simplified example of the content similarity. Here is a category on installation. You are presented two categories of installation, and each category of installation presented failure. The similarity, the algorithm is the objective, the aim of the algorithm is to regroup all installation are same failure. Of in this picture, there are A and C are same failure, and the objective is to make rapport between installation are all, same failure and all installation presented failure. And the aim is to use two methods for two methods for what is please?
Yes, Bala, it was really very nice and appreciating presentation given by you. And it was really very nice work that you have worked for the rural development. So very congratulations to you. Thank you.
Now moving forward, now I would like to call our next presenter to present his paper on natural language processing of South African online questioning answering health forum HIV and AIDS database dataset using topic modeling. Kyle Stone.
Just lost my Zoom window. Get it back now. Hello, everyone. I assume you can see my slide now.
Yes.
Yes, I'm Carl Stone from Tshwane University of Technology in the Computer Systems Engineering Department. My supervisor is Prof. Ojo and the co-supervisor is Prof. Du. So the title for this is called Making Extinct Data Useful, a Journey, and you'll see why I've titled it that way soon. So first of all, what is the problem that we were looking to address with this whole project? So the social aspect, HIV in Southern Africa is still quite a large problem. We have between 1.4 and 2.3 million new infections. That was just in 2018 alone. And between 550,000 and 1.1 million deaths, as according to UN AIDS data. And even though it's such a big problem, the knowledge regarding HIV and AIDS is still quite poor, with about 45.8% of people between 15 and 24. That's the amount of people that can actually identify means of transmission. So that's just basic AIDS knowledge. So in terms of us, how can we help? Can natural language processing actually be helpful in this context? And can we perform topic modeling on the questions for then to later on be used in chatbots? So what do I mean by extinct data? Well, the data that I got is from a South African e-health forum. And this was answered by medical doctors. So what basically happens is people ask their HIV and AIDS questions, and then actual medical doctors go and give them answers. And this forum is no longer accessible. So fortunately for me, I just managed to get all the data, and then the website, they ended the service basically. So the data is no longer there. So we can now use this data to do something like a chatbot. So why would we do that? Would be, there's fast response time. You ask a question, you get immediate feedback. It's available 24 hours. You get consistent answers, and it allows you to gather more data while the chatbot's being used. You gather the data and you can learn from that. So how will we get there? So this is just a flow diagram taken from my paper. So we gather the data first, we store that, we have to then clean that data. Sorry, my mouse is on the wrong screen. We then clean that data. We then do pre-processing and apply NLP to that data. That'll then give us the topics, and then we can analyze the topics. So that's where we started this in this paper. So to do the data gathering, I implemented Python web scraping. So this, of course, involved inspecting the HTML of the site, writing the script to scrape the page, and then due to the nature of how the data was organized, we needed to use Selenium to click on various elements on the page to get all the data. This is just a snapshot of the data that was collected. So there were around 2,000 questions. Then in terms of data cleansing, the data, as you can imagine, was very messy because it's entered by humans on their mobile phones, and it was very, very messy. So it required lots of cleaning, and obviously also poorly spelled quite often, and it needed to be anonymized for obvious reasons as well. So you might think initially that to fix the spelling wouldn't be much of an issue because there are autocorrect features and various techniques that you can use to fix the spelling. So this is an example of something that I just tried initially to see what the effect would be. So you just run each word through an autocorrect essentially. And that was definitely not that simple. This is an example of of one question of what happened. So the first question is, hi doc, what does RVD mean in HIV positive patients, and how soon can you start with ARVs? So once you run that through the spelling correction, it turns into, hi doc, what does red mean in HIV positive patient? How soon can you start Arabs? So of course, that's not at all what the person's asking anymore. So that was the problem with just blindly running it through autocorrect. So what we did to fix that was first of all, we have a list of all the words, such as acronyms commonly used acronyms with HIV and age, and we exclude them from the spell check. So that did help a bit, but you'll see later on what the effect was on the data itself. So in terms of the pre-processing, we need to do tokenization. So that's basically putting each word into its own little token. So these pieces are called tokens, and it's a process where certain characters and punctuation is discarded. So it's basically, to put it in a nice way, it puts the word in a small little package. Then case transformation. So we just needed to make everything into lowercase, filtering out all non-alphabetical tokens. Now, importantly, you have to exclude measurements, because often people would ask questions regarding their dosages or medication, for example. So we need to leave that in. We need to remove stop words, so words that don't really give much meaning to a sentence, like a, and, but, how, etc. And then we had lemmatization. So in this step, we take different words that have the same meaning and replace them with one single word. The other important fact that we looked at was n-grams. So that basically, if you look at the example over here, it says for a sentence, either my way or no way. So when you're using 1 gram, each word is on its own. With 2 grams, it breaks them up into words of 2 or couples. So it's either my, and then my way or no way. And then 3 grams breaks it up into sets of 3. You can see there with the colors, then 4 grams, and so on. So what we did was we also looked at the effect of these using the n-grams and seeing what effect that had on the topics that were generated, which we'll see later in the graphs. Then we have the LDA. This is what we actually use to do the topic modeling. So it's a popular generative statistical model. It's used to discover topics and classify documents from a corpus. The one issue with it, though, is that it cannot label the topics. So once we use the LDA, we then had to go and apply manual labels to the topics that were found. Okay, so now we get to the interesting bit. So this is the results. This is after we've applied LDA to the data that we had cleaned. So if you look at this one over here, this is the topic distributions for no spell check and no n-grams. So what we did was we ran it first without using any spell check and without using the n-grams. So we also tried it with a number of different topics to see which one worked best. So if you see here, this was done with 5 topics, 6, 7, 8, and 9. And you could see, for example, when you have too many topics, what tends to happen is, or in this case anyway, it put too many in topic number 1, which doesn't make sense if you look at the corpus itself, because there's a wide array of topics in the questions. So to have them all in one big lump like that is a good indication that something was wrong. The one that looked the best from this one was the 7 topics one. And upon closer inspection as well, you could see that it did a very good job of sorting the questions according to topic. Then we have the results for topic distributions with spell check and no n-grams. So this is just having the spell check applied to it and without using the n-grams. And this was, you could see immediately that something's off because it's pulled them all into 2 main topics often. And again, just because of the nature of the questions, there's far more than just 2 main topics that are being asked. So this one was also pretty much discarded for that reason. But we did look in more detail in terms of the questions that were asked there. Then we have no spell check and with n-grams. So this one did even worse and put everything for most of them into one big clump. So you can see that this cannot be valid. Again, because if you look at the individual questions, there are far more diverse topics in the questions themselves. And in the last one, we looked at spell check with n-grams. So this one appears to be an improvement on the previous one. Okay, obviously, but it still clumps the questions too much into two primary topics, and it was just also discarded for that reason. So the one that actually performed best then was the first one with no spell check and no engrams, and the 7 topics one. So in the paper, we go into more detail and we look at why some others were discarded, but the one that performed best was the one with 7 topics without spell check or the engrams. So just to conclude, we look at what those actual best topics look like. So you'll see this is the 7 topics starting from 0. And you can see the words associated with each topic and the label, the topic label that we assign to it. So remember, these labels are coming from us. So sometimes it's easy to see what the topic is just by the topic words themselves. Sometimes it's not the case. So when it's not the case, you have to go in and you look at the questions themselves that are labeled with a specific topic number. And something interesting that happened here is if you see topic number 0, it was quite strange in terms of some people asked questions that were completely unrelated to HIV and AIDS. So it was interesting to note that it actually filtered them out essentially. So going on with future work, we know that we can just exclude topic number 0 from the set because it's not related to HIV and AIDS at all. Yeah, so for the others, we had to sometimes go deeper into looking at the individual questions to see what the actual topic label should be. Yeah, thank you.
Thank you, Keystone, for the nice presentation.
Thank you.
And fixing the spelling given very nicely. Just wanted to know, you are shown many results, right? So you have checked your results with current other authors or researchers' work.
Sorry, can you repeat the question?
Have you compared your results with current work which is available through other researchers?
On other data sets? No, yeah. I haven't done that, no.
So it is needed.
Because I haven't seen other similar work in terms of, well, specifically on the South African data sets. I haven't looked at others though.
You can, yes.
That's a good idea.
Yeah. Yes. Yes, Keystone. Yes. Your work was very innovative and very nice presentation. I would like to ask that when you are doing data cleansing, you're using data cleansing techniques there. So you're removing, you're having spell check and all the other methods. What are you doing with the special symbols like question mark, full stop, comma, hashtag? The special symbols, have you filtered or have you done anything with it?
Yeah, so as I mentioned, there was a lot. So the first step when you do data cleansing is just to look at the data itself to identify where the problems could be. So as soon as we did that, we saw people included their cell phone numbers, for example, email addresses, funny characters because they type on their phone, you know, if you push a button too long, it puts a funny character instead of what they wanted. So one of the first steps was just to filter all that out. And one of the steps of data cleansing is also just to remove punctuation itself. So because the algorithm doesn't use the punctuation at all for the natural language processing.
Yes, okay, thank you. But I also have done the work on NLP, but what I have found it that the question mark or semicolon, comma, full stop, they are making sense. They are giving sense to the sentence. So we should work out on it. Yes. Thank you. It was really very nice.
Okay, thanks. I'll look into that.
Yes. Yes. Over to you, Richa, ma'am.
Sure, ma'am. Now we can call our next presenter. to present his paper on data mining to support decision making, a research approach. The present paper presenter is George.
Hello, I'm Ware. Good afternoon. I want to start by congratulating the organizing committee of the conference. Very well. Let's start the presentation of the paper. Data mining to support decision making and research approach. Points of agenda, introduction. I can start. Very well. Let's start presentation of the paper. I begin. Agenda, introduction, objectives, methodology, conceptual model of regression and classification models in data mining, discussion and conclusion. Introduction. The exponential growth of data requires the use tools like data mining. This method allows the extraction of data from business intelligence, big data, and data warehouse to create a consistent systematization of parts that can be molded to meet customer needs. Technology is fundamental and priority of quality and systematization of information, as well as for creation of standards using data mining techniques. As a result of the large amount of data generated daily, data mining allows to create of standards to automate process and organization to have organized information to support decision making. The work contributes with a data mining model to evaluate the data and lead to technology management. The object of this work is to contribute with data mining model, which allows the evaluation of data and lead to technology management from the analysis and treatment of the data received, and to present examples of creation of data mining models. Next, objectives. The data mining environment allows to use of techniques for the design of patterns, considering the data obtained from the emergence of new technologies such as cloud computing, web data, and big data warehouse in data science area to allow companies to formalize a strategy for decision making. The process of discovering technology in a database consists of 5 phases. This phase is very important. This model selection, definition of objectives, as well as the selection of data for technology discovery process, pre-processing, improve data reliability, data archivality, and clean it to make them consistent. The transformation, develop the best data models to obtain quality information. The data mining, definition of the choice according to the objectives defined in previous steps, and the evaluation or interpretation outline the end of technology discovery process in database or readjust the patterns, the repeat the process. The process of discovering technology in database to identify valid new pattern based on useful and understandably data based on existing data are not trivial, but crucial for obtaining organized information that supports decision making. The data mining process with data mining allows the creation of relationships and patterns to present data in an innovative way to users. Data mining objectives can be divided in two broad categories, which are divided in subcategories according to the purpose of their use. Data mining, prediction, inscription. Prediction figure allows the identification of forecast category, consists of classification and regression, as well as the description category consists of association, summarization, segmentation, and visualization. Classification. Classification is the process according to your class and the resources. Regression allows you to define a variable to predict to decision, that is how a person survives based on test results. The association determines the data that will tend to compete for the same reproduction in a market, placing products in the grocery cart, market basket analysis. Summarization is the most advanced technical method derived from visualization summary rules and finding relationships between variables applied to data analysis and report. An aggregation or clustering allows for heterogeneous division of a population into several homogeneous segments with clustered similar data. In visualization, data mining results are presented through graphs and diagrams, allow a representation of patterns and trends. Very well. Is next the methodology used. The methodology adopted in this work is design science and research, DSCR, for solving organizational problems and allowing the production of innovative artifacts. Very well. The figure describes a design science research methodology consists of 5 phases. The tasks are continuous and controlled to guarantee the success of the work. The architecture of various storage technology in the systems, architecture designed for business as business integration. In developing data are modeled or in the dimensions close to reality. The evaluation of the model is important for the results to be obtained. The life cycle converges in the implementation, bringing together the technological solution and data handling. The maintenance phase is very important in the whole process. In all engagements and limitation and risks must be guaranteed, whose organization's objective is business acceptance to support the decision-making process. Is the methodology used. A conceptual model of regression and classification model in data mining. The main objective is present the conceptual model in data mining from the data source, process if the cleaning and formatting of data, the KPIs for analysis and presentation of the data and the creation and the regression and classification models in data mining. In the figure, we can observe two bases for the acquisition of technology and the development of a solution. 4 points important. Point 1, data knowledge acquisition, data collection and study, problem classification, solution design, selection and aggregation of research data. Development of the solution. 3 points, data preparation, ETL process, creation of the OLAP cube, and models in data mine. Analysis of data and requiring through a proof of concept from data set. 2, modeling the data warehouse design and implementation of ETL process, dimensions and facts tables. Analyzing service multidimensional project, OLAP cube to KPIs, multidimensional and data mining design for data mine models, preparation for business intelligence, continue in data mine classification. Algorithms allow for predicting one or more discrete variables based on the other attributes of the dataset. Regression algorithms allow you to define one or more continuous numeric variables, such as profit or loss, based on the other attributes of dataset. Algorithms such decision-free, naive-based, clustering, and neural network are some of the examples of algorithms to be considered in the regression and classification models in data mining. Data mining is very important, is used the algorithms in the work. To consider for the conceptual model, an algorithm in data mining is a set of heuristics and calculation to create a model based on the data. To create a model, the algorithm first analyzes the data we provide and looks the specific types of patterns or trends. The algorithm uses the results of the various interactions that define the optimal parameters to create the mining models. Parameters are applied across the entire data set to extract patterns and detail statics. Is the any algorithms to use in the data mining to create someone KPI to business intelligence. Some final truth. The importance of data mining to support technology management for organizations. Data must be extracted and explored from systems to be systemized, creating patterns using data mining techniques, allowing the automation of process. The state of the art allows the study and characterization of platforms, applications, and systems for the process of discovering technology in database. The methodology used allow contextualization the work through the creation of artifacts, considering the extraction, exploring, and systematization of data for models regression and classification in data mining. The DSR methodology made it possible to identify and solve the problem with the creation of the cataloging typology, which identifies the data extraction and exploring tools that best suit the needs of users to work, as well as for determination or regression and classification algorithm in data mining. The algorithm present and which can be applied from an interactive and multidimensional environment contribute to improving the decision process in scope of data science in data mining applied to technology management. Thank you. I end my presentation. Thank you for the opportunity given. Thank you and grateful for attention. I would like once again to congratulate myself on participation in conference. Congratulations to all and thank you very much.
Thank you, George, for the nice presentation on the demanding topic. So data is important nowadays and we are handling a huge data. So what type of security you are providing your work?
I'm sorry.
Security.
Security is the information?
Yeah.
Very well. Security, the information, I'm sorry. Is information security guaranteed is a question?
Yeah.
Is information is the data set used in the work is collected in data source in data source data set is data set is
which George, which different data sets you are handling?
I'm sorry.
Which different data sets you are handling in your work?
A different data set is used. A different data set used in this work.
Yeah.
Different data set is used in the work is to is collected in platforms, right? Is in platforms in platforms open source. Is the information is collected in various data sets. Can I use to work developing this paper? This work is platforms open source is not is algorithm, right?
Okay, thank you, George.
About data mining is very important, but it's not illegal.
Thank you, George. Over to Varsha, ma'am.
Yes, ma'am.
Thank you.
Yes, your work is good, George. And have you any future plans to implement it practically? And what methodology you will be using, if so?
I'm sorry?
Will you implement it practically in future?
Yes, I implemented this work is implementation in practice. Where data mining is used in the the companies.
Okay, thank you.
Very
thank
good.
you, George. Thank you very much for your input. Thank you.
Thank you.
Over to you, Richa ma'am.
Yes, ma'am. Now we'd like to call our next presenter to present is a paper on sustainability of digital transformation, institutional research, and information and communication technology in higher education based on edu-informatics.
Hello everyone, my name is Kunihiko Takamatsu. Today, my title is Sustainability of Digital Transformation, Institutional Research and Information Communication Technology in Higher Education, based on edu-informatics. This work is with Ikuhiro Noda, Kenya Bannaka, Katsuhiko Murakami, Yasuhiro Kozaki, Aoi Kishida, Hiroki Kabutoya, Kenichiro Mitsunari, Ryohei Adachi, Masato Omori, and Yasuhiro Nakata. Today, I have three topics. The first topic is introduction and research question. The second topic is about practical examples. And the third topic is conclusion. Now I start introduction and research question. This slide shows a recent key term in higher education. Evidence-based education, EBE, institutional research, IR, learning analytics, LA, information and communication technology, ICT, digital transformation, DX. This slide shows the Society 5.0. Society 5.0 first spread into the business field through Japan Business Federation. The concept of Society 5.0 has an easy link to the concept of Sustainable Development Goals, SDGs. I think many people know the field of bioinformatics. Bioinformatics is the word or field combination between biology and informatics. To quicken this research, we propose the concept of edu-informatics, a novel field of education that combines both education and informatics. In 2018, the term is a portmanteau of education and informatics. This figure shows the concept of edu-informatics. The field of education provides problems to be solved to edu-informatics. Edu-informatics deals with students' data and provides novel analytical methods and concepts for using data in education, similar to bioinformatics. In this research, we set research question is following. How do we obtain sustainability in DX, IR, and ICT to improve the quality in higher education. The next is second topics. Next, I introduced you about the layers of learning analytics defined by UNESCO in 2012. As you can see, there are 3 layers. The top layers is the macro levels, and mid layers is meso levels, and macro levels. Macro level analysis seeks to enable cross-institutional analysis. For example, maturity surveys of current institutional practice, and another example is improving statewide data access to standardized assessment data over student lifetimes. The next step, meso levels, the mid layer. The next step is meso level. Meso level analytics operate at institutional level. So, in IR, we deal with these levels. In this level, we can use business intelligence to BI tools to analyze data. Finally, I introduce to you the micro level. Micro level analytics support the tracking and interpretation of process level data for individual learners. And this data is of primary interest to learners themselves and those responsible for their success, since it can provide the finesse level of detail. Again, I show the 3 layers figures. In 2019, we presented new proposal to compare student data in institutional research in the conference of DSIR 2019. This is the definition, a linear function combination. In last year, we provide the definition, primary and secondary data like this. Primary data is not linear combination data, and secondary data is a linear combination of primary data. And we show the example of primary data at macro level. Correct or incorrect answer to a question in an examination, or students' attendance in and absence from a lecture. And an example of secondary data at micro level. The total points in an examination and student total attendance in an absence from a lecture. And example of the secondary data at meso level. For example, student records of lectures as well as grade point average GPA. And another example is rank in the annual record of university. Most secondary data for students in a university is calculated as linear from primary data. But, for example, in item response theory, IRT, the ability of student is calculated by maximum likelihood estimation, MLE. So, in this case, the value of the ability of student is clearly secondary data. But the value of the ability of student is not linear data because the value was calculated by MLE. So, in this year, we redefine the definition of the secondary data. Our new definition of secondary data is involving not only a linear combination of primary data, but also a non-linear combination of primary data.
Next, we introduce about example 2. We published the paper. The paper title is University Reform by Significant Other Groups in Informatics. Before this research, maximum members who belongs to university reform are stakeholder. So we expanded and defined this stakeholder to significant other groups. SOGRs includes not only faculty, staff, but also undergraduate and graduate student and other institutors. From 2 examples, we define and construct a new matrix about sustainability and feasibility.
The final topic is conclusion.
Again, we showed our research question. Our research question is, how do we obtain sustainability in DX, IL, and ICT to improve the quality in higher education? This figure shows the answer of this question. The combination of ICT, LMS, data, informatics, education-based learning, or IL, or learning analytics, and these combination continue to sustainability.
Thank you for your attention.
Thank you, Punito, for nice presentation. For your work, which BI tool you are used for the data analysis?
Mary, now I use JUMP. Do you know? Like a SAS.
Okay. Why you are used that only? Because many BI tools are available in the market. Why you are choosing that only?
Yeah. So JUMP is made based on the SAS. Mainly, we use SAS because our main research is bioinformatics. So it is very useful for me. But now I use not BI but the Python or language or R language or something. So we use many tools.
E-tools. Okay. Okay. Thank you. Thank you.
Thank you.
Over to ma'am. Madam, you are not audible. Varsha ma'am.
Yes, ma'am. Yes, thank you, ma'am. Yes, it was very nice, innovative presentation. Kunishiko Takamasu. Am I right? Yeah. Yes. Very, very nice work. Good research work done by you, and really appreciate you. Thank you very much.
Thank you very much.
Yes, over to you, Richa ma'am.
Thank you, ma'am. And we have completed all the presentations. I sincerely thank our authors for their excellent presentation and contribution in this conference, and all our participants for being a part of this international conference. Thank you so much, everyone. I hope this session was informative enough. And we on behalf of the whole team, thank you for your support in this version and the previous version. And we will be happy to have you in the next version of this, seventh version of this conference in 2023. And thank you so much, everyone. All the presenters would be getting digital certificates and via email within 2 to 3 working days. And all the papers have already forwarded to the Springer, and publication will be live within 5 to 6 months. Kindly be cooperated with the team of WS4. And I also thank our chair for this session, Dr. Latika ma'am and Dr. Varsha ma'am. Thank you so much, ma'am, for chairing this session and for your valuable time.
Thank you, ma'am. It was really very nice. And I really feel very honored and delighted to be the session chair for your conference, that is World 4, S4.
Yes, World S4.
Yes. I'm thankful to Dr. Amit Joshi also, and also a very heartfelt thank to Richa Sharma for your kind invitation. And yes, the contents of all the papers of all the authors, they were really very nice. They were very, very interesting, and all the authors, they have presented it with great zeal and enthusiasm. And actually the delivery of the lecture was in such a kind that I lost my track. And I was really involved in all the new innovative ideas which the researchers have presented. And I have learned a lot, many things from them. So the research where it should have been won. So I wish all of you, all the researchers, all the presenters, a very best of luck for your future endeavors. And once again, thank you for the team World S4 for inviting me. And Richa ma'am, I have a request for you that please do send us the photo which you'll be taking it virtually.
Sure.
Yes, Dr. Latika ma'am, it was really very nice meeting you virtually. Thank you.
Thank you, all the researchers. They have presented the paper very nicely. But one submission I'm keeping, always continue the same, because society needs it. And thank you, GR Foundation, for involving me for this 6th World Conference on Smart Trends in Systems, Security and Sustainability. Thank you, Aman sir, Amit sir, and Richa too. Thank you.
Thank you, ma'am. And I kindly request to everyone, please turn on their camera for taking a quick snapshot. Thank you so much, everyone.
Thank you. Have a good day.
Stay safe and take care, everyone.
Thank you very much.
Bye-bye. Thank you.
Bye.